Imagine a world where machines can build themselves. Not just assemble pre-made parts, but actually create more of themselves. This is the tantalizing promise and potential peril of self-replicating robots. We stand at the cusp of this technological revolution, a revolution with the power to reshape our world in ways we can only begin to imagine. The very idea seems ripped from the pages of science fiction, but the reality is closer than we might think. Scientists and engineers are making remarkable strides in the field of self-replicating systems, drawing inspiration from the biological world that has been doing this for millennia. This is not merely about creating mechanical copies. It's about harnessing the power of exponential growth and autonomous construction. The implications are staggering, touching everything from space exploration to manufacturing, medicine to environmental remediation. But as with any powerful technology, the potential benefits come hand in hand with profound ethical questions. Nature has been in the business of self-replication for billions of years. From the simplest single-celled organisms to the intricate dance of DNA replication, that life itself is a testament to the power of self-assembly. It's no wonder then that scientists and engineers are looking to the natural world for inspiration in their quest to create self-building robots. Take, for example, the humble DNA molecule. This microscopic marvel contains all the instructions needed to build and operate a living organism. Scientists are exploring ways to translate this biological code into the language of robotics, creating machines that can assemble themselves from molecular components. Another source of inspiration comes from the world of cellular biology. Cells are masters of self-organization, replicating and assembling into complex structures like tissues and organs. Researchers are developing robotic systems that mimic this behavior, creating swarms of tiny robots that can cooperate to build larger structures. By understanding and emulating the principles of biological self-replication, we can unlock the secrets to creating truly revolutionary robotic systems that can adapt, evolve, and construct themselves in ways we can barely imagine. Building a machine that can build itself is no easy feat. It requires a convergence of cutting-edge advancements in materials science, computer programming, and robotic engineering. Each element presents its own unique challenges and opportunities. One of the key hurdles is developing materials that are both strong and adaptable, capable of being formed into intricate shapes and assembled with precision. Three-dimensional printing has emerged as a promising technology, allowing for the creation of complex components with customizable properties. But materials are just the building blocks. The real brains behind self-replicating robots lie in their programming. Engineers are developing sophisticated algorithms that allow robots to perceive their environment, make decisions, and execute complex assembly tasks. This requires a deep understanding of artificial intelligence, machine learning, and robotics. The engineering challenges are equally daunting. Self-building robots must be designed with modularity and redundancy in mind, able to repair themselves and adapt to changing conditions. This requires innovative approaches to mechanical design, power management, and communication systems. A key concept in the development of self-building robots is modularity. This involves creating robots from interchangeable units or modules that can be combined in various ways to create different structures or functions. Think of it like building with Legos. Each brick is simple on its own, but when combined, they can create an endless variety of structures. Modular robotics takes this concept to a whole new level, with modules capable of self-assembly, reconfiguration, and even self-replication. This approach offers several advantages. It allows for flexibility and adaptability, with robots able to change their shape or function to suit different tasks. It also enhances resilience, as damaged modules can be easily replaced without having to rebuild the entire robot. Modularity is also crucial for self-replication. By creating robots from identical modules, it becomes possible for them to assemble copies of themselves using readily available components. This is a key step towards creating truly autonomous self-replicating systems. Section 5. Reaching for the stars, applications in space and beyond. The potential applications of self-building robots are vast and varied, with the potential to revolutionize industries and solve some of humanity's most pressing challenges. One area where this technology holds immense promise is space exploration. Imagine sending a single spacecraft to Mars, carrying a payload of self-replicating robots. Upon arrival, these robots could use local resources to build a habitat, mining equipment, and even vehicles, creating a self-sustaining colony long before the first human sets foot on the red planet. But the potential extends far beyond our own planet. Self-building robots could be used to construct telescopes on the far side of the Moon, shielded from Earth's interference. They could build and maintain infrastructure in orbit such as space stations or solar power satellites. And it's not just about space. Self-building robots could revolutionize construction here on Earth, building bridges, tunnels, and even entire cities with unprecedented speed and efficiency. They could be deployed in disaster areas, clearing rubble, building shelters, and providing aid to those in need. Section 6, a double-edged sword, ethical concerns and unintended consequences. The prospect of self-building robots is undeniably exciting, but it also raises profound ethical concerns. Like any powerful technology, self-replication has the potential for both great good and great harm. One pressing concern is uncontrolled replication. What if a self-replicating system malfunctions and produces copies without limit? Could we face a scenario like the grey goo hypothesis? Another concern is autonomy. How do we ensure robots remain under human control? What ethical framework should guide their actions? And then there are economic and societal impacts. Will self-building robots lead to job displacement? How will they affect wealth distribution and social inequality? These are complex questions with no easy answers. Section 7 pioneers on the horizon, current research and prototypes. Research in self-building robots is progressing rapidly despite challenges. Universities and tech companies worldwide are making exciting strides. MIT's Center for Bits and Atoms developed modular robots called digital materials. These robots can self-assemble into various structures. Swarm robotics is another promising research avenue. Harvard's kilobots can self-organize into different shapes. Expect more innovative prototypes as research advances. Section 8. The Promise and the Peril, a Future Shaped by Self-Building Robots. The future of self-building robots is a tapestry woven from threads of both promise and peril. On the one hand, this technology has the potential to solve some of humanity's most pressing challenges, from climate change to resource scarcity. Imagine self-building robots deployed to clean up pollution, plant trees, or build sustainable infrastructure. Imagine them constructing affordable housing, providing disaster relief, or even exploring the depths of our oceans. The possibilities are limited only by our imagination. But this potential comes with a heavy responsibility. We must proceed with caution, carefully considering the ethical implications and potential risks of this technology. Unchecked development could lead to unintended consequences, from economic disruption to existential threats. The future of self-building robots is not predetermined. It is a future we will shape through our choices, our values, and our commitment to responsible innovation. It is a future that demands both our ingenuity and our wisdom. Section 9. Steering the course responsible innovation in a new era. As we stand on the brink of this technological revolution, it is imperative that we proceed with both enthusiasm and caution. We must embrace the potential of self-building robots to improve our lives while simultaneously establishing safeguards to prevent unintended consequences. This requires a multifaceted approach involving collaboration between scientists, engineers, ethicists, policymakers, and the public. We need to foster open dialogue, encourage responsible research practices, and establish clear ethical guidelines for the development and deployment of self-replicating systems. Education is also crucial. We need to educate ourselves and future generations about the potential benefits and risks of self-building robots, empowering them to make informed decisions about this transformative technology. Ultimately, the future of self-building robots is not something to be feared, but rather something to be carefully considered and thoughtfully guided. By embracing a spirit of responsible innovation, we can harness the power of this technology to create a better future for all. Section 10. Our Choice, Our Future, Navigating the Crossroads of Technology and Humanity. We stand at a crossroads in human history where rapid technological advancement intersects with profound questions of our values. Self-building robots remind us that our creations can reshape our world and ourselves. The choices we make today will determine the impact of this technological revolution. Will we harness this power to solve challenges and create a just, sustainable world? Or will we let it exacerbate inequalities or pose existential threats? The answer lies in guiding its development to align with our values. The future of self-building robots is a future we will write together through our choices and actions.